You're going to be taking the Regents exam probably June 2025, if I had to guess. If you're watching this video, congratulations for you. You're well on your way if you're checking out questions on your own. We are going to walk through part A of the exam. This is the January 2025 exam we're going to use as our example for your exam. It's all multiple choice and it's all definitions and facts. You have to know these things in order to do well on this exam. And I want to show you something to make sure you understand what you're up against here. This is the scale. They don't call it a curve, they call it a scale for the Regents exam from January. Pretty much it's the same from one Regents to the next. In order to get a 65 on the exam, you have to answer 50 questions correctly. I just circled it so you could see it. Since part A is worth 30 points because there's 30 questions, that is going to really give you a big advantage if you can get all or at least most of those questions correct. And there's no reason that you can't because, again, facts, definitions. Let's take a look. Okay, so starting with the first question here, we're talking about subatomic particles, right? Those are the protons, neutrons, and electrons that are in an atom. But in this case, they want to know what's in the nucleus for an oxygen atom. Well, you have to remember that your protons and your neutrons are in the nucleus and the electrons are on the outside. It's a fact. Know it. For question 2, which phrase describes the charges and numbers of protons and electrons in an atom? Well, again, you have to remember protons are positive, electrons are negative, right? Neutrons, sometimes you'll hear somebody say zero charge or neutral. We're specifically, though, talking about protons and electrons. And key also is we're talking about an atom. Atoms are electrically neutral. What that means is the number of protons equals the number of electrons. So equal in number, but they have opposite charges. This is what I call a 2-for-1 question. You have two answers, right, for the one question you have to be able to get correct. So they have opposite charges, so right away, cross out 3 and 4, and then they are equal in number, which is choice 1. For question 3, in the wave mechanical model, boy, does that sound very fancy. It actually is very fancy. That is our current present-day model of the atom, which term identifies a region in an atom of lithium that is the most probable location of electrons in the ground state. This is the definition of what we call an orbital. So while the first two questions were about facts, question 3 is really the definition of the word orbital. Question 4, you have an atom of C12. The capital C represents carbon. It's in the ground state, meaning that the electrons are in the lowest energy levels available, and an atom of carbon 13 in the ground state. And they are defined as isotopes of carbon because these atoms have the same number of protons. Really, what they're asking here, the definition for an isotope. You have the same number of protons, but a different number of neutrons. Isotopes, you don't have to worry about anything with electrons. Same number of protons, different number of neutrons. All right, let's check out and dissect question 5 here. At STP, well, the first thing you have to know, what in the heck is STP? Standard temperature and pressure. Now, why is it even here? Well, it says which property can be used to differentiate between a 2-gram sample of oxygen as a gas and a 2-gram sample of helium as a gas. Well, standard temperature and pressure is used when it comes to gases. This is saying that the oxygen and the helium samples are at the same temp and are at the same pressure. So what is going to be used here in these choices to differentiate between the two? It's not going to be mass because they're both 2 grams. That's not going to work. It's not going to be temperature because they're both at the same temperature. Well, it's going to be reacting with sodium. Helium, as a noble gas, doesn't react with anything. However, oxygen will. The phase of each sample, again, can't be that. They're both, you have the G's in parentheses, which means that they're both in the gas phase. So your answer here is 3. Now, this is a kind of a new question. I haven't seen it worded this way in a very long time, if at all. So that's why you want to practice also as many regents as you can to get an idea of the types of questions that are being asked and the ones that repeat a lot. Let's check out 6 because this is a perfect example. How do the molecular structures and properties of oxygen as O2 and ozone as O3 compare? Now, these two would be known as allotropes. And it's interesting because New York State, in all these years, will have a question like this about allotropes on the test, but never use the word allotrope, which, again, I find is odd. Anyway, what happens is they have different structures. In fact, each molecule, this is 2 oxygen atoms for each molecule and 3 oxygen atoms for each molecule. And since the structures are different, their properties are also different, which here, of course, then is choice 2. Checking out question 7, which substance can be broken down by chemical means? And look at the choices. I have aluminum is an element. If I break aluminum apart, it's not aluminum anymore. Ammonia, well, that's my answer because part of the properties of a compound is that I can break them apart. And remember, a compound is 2 or more different elements chemically combined, in other words, bonded together. And ammonia is NH3. It's definitely a molecule you're going to want to know. You're going to want to know the bonding of the molecule inside and then the type of molecule it is. Polar bonds, polar molecule, and that'll come up actually with question 9. Now, argon, element, and arsenic, element. What if you didn't know it all and you were thrown off? Well, we haven't talked about the reference tables yet, but you do have your chemistry reference tables and you do want to refer to them. You're not going to refer to them very much in part A here, but it might have been helpful in question 7. And let me show you why. Reference table S gives you all of the symbols and then all of the names of the elements associated with the symbols. You could just have looked them up and realize then that ammonia is not on this list, is not on reference table S. When you're practicing questions, you should have your reference tables out. You should have a pen and some paper. If there's facts or definitions here in part A that you don't know or don't remember, I would write them down. That's the best way to do it. And it's something you can refer to up to the day of the test to make sure you have it in your brain to answer those questions correctly. Now, question 8, which type of bonding is present in a sample of zinc at STP? Zinc is on the reference table. It's Zn, and it's a metal. The type of bonding we have with metals, yeah, it's not a stretch here, is metallic bonding. Should you know all of these? The answer is absolutely yes. Covalent bonding is between nonmetals. Hydrogen bonding is actually not a bond per se. It's a molecule to molecule attraction, a strong attraction, but it's called hydrogen bonding. That's the terminology that's used. Ionic bonding, that's your salts. That's between a metal and nonmetal or nonmetals. But when it comes to metals, it's metallic bonding. For number 9, which formula represents a non-polar molecule? So now we're talking about bonding. It's the electrons in atoms that set up bonding and how elements are going to combine. Then from there, the bonds themselves, again, are set up between two different atoms or two of the same atom. And then when you have molecules, which are all your non-metal bonds, then you have also a description of whether or not it is polar or nonpolar. Nonpolar means that the electrons are traveling around the molecule essentially with symmetry. In other words, there's no separation of a negative end because there's more electrons kind of hanging out on one end of the molecule versus another, versus a polar molecule where that is the case. There's a couple of ways that you can deal with polar and nonpolar molecules. One way is just to memorize them. New York State and this standardized test pretty much follows the same types of questions every time. So you're not really going to get something totally out of left field. That's one way. The other way is you'd have to know the structure of the molecules. So let's take a look at these four. CH4 is methane. This is known as a tetrahedral because all four bonds are equal. I mean, this looks like a plus sign, but three-dimensionally it's called a tetrahedron, and that makes CH4 a nonpolar molecule. If I take HCl, now I have just two different elements bonded together. Chlorine wants the electron pair that's being shared more than hydrogen, and it sets up then the electrons hanging around more of chlorine than hydrogen. Water, again, polar. You have water with your bent shape. Sorry for my drawing here. And you have electrons up here as well. So you end up with a negative end up here and a positive end down here. And ammonia, which is the pyramidal shape, it's going to look like a T when I draw it two-dimensionally, but three-dimensionally it is a pyramid. And again, I have a polar molecule. The charge, we call it asymmetric because the electrons are hanging out more around nitrogen than they are around the hydrogens. So my only answer here is CH4. Now, besides CH4, my typical nonpolar molecules that show up on the test, carbon dioxide. Now, this is an interesting one because while the bonds are polar, because you have two different nonmetals bonding together, the overall symmetry makes it a nonpolar molecule. And your nonpolar molecules, because of nonpolar bonds, are your diatomics. So again, CO2 and CH4 have polar bonds, but due to symmetry are nonpolar molecules. Then your diatomics, nonpolar bonds, nonpolar molecules. Now, if I'm going too fast, I would stop, rewind, go through it again. I'm also going to share in the description my year in review sheets I used to give my students. I am a retired chem teacher at this point, but I still love going through questions and helping any student that's out there. And I will put a link in the description, and I would highly suggest you take a look at it and read through it. Checking out question 10, given the equation representing a reaction, what occurs during this reaction? This is two fluorine atoms becoming a fluorine molecule. What occurs during this reaction? Well, is energy absorbed or released? If you're not sure which is which, let's go back to the back half of the answer here. We have two atoms coming together. Obviously, a bond is formed. Cross those out. Now, the question is it absorbed or released? The way that I always taught my students to remember it, if you break your arm, energy has to go into breaking that arm. Maybe, I don't know, something fell on your arm or you got tackled by somebody. So to break your arm, energy went in. Same thing with bonds. If you're going to break bonds, energy has to be absorbed. In this case, a bond is forming, So energy is released, which is choice 2. Try to relate things back to what you know, and that's going to make remembering it even easier. For question 11, we got to go to reference table S. It says an atom of which element in group 16 has the greatest attraction for electrons in a chemical bond. Well, here's the definition again. This definition is for the word electronegativity. You have to know it. It shows up, just like the word isotope showed up already. Allotrope, even though the word wasn't used, showed up already. Electronegativity is going to show up on your test. We go to reference table S and let's check it out. There is a column for electronegativity, and what I've done is I've circled here for oxygen, sulfur, selenium, and then, trust me, tellurium is underneath. And you can tell that the highest value is for oxygen. Oxygen wants the electrons that are in that bond closer to them, and that's my answer. So we're talking here choice 1. For question 12, a solution is made by completely dissolving a sample of sodium hydrogen carbonate in water. This solution is classified. Anytime you have a solution, you have a mixture of 2 or more substances, and solutions are homogeneous mixtures. They're going to look the same throughout. Okay, they're just physically combined. They're just present with one another. Okay, they are not chemically combined as a compound, and that makes the answer choice 4. Now, the other thing with solutions is that, let's say I have a solution of, I don't know, sodium chloride. I'm just using that instead of the sodium hydrogen carbonate because it's less to write down. What you're going to see, anytime you see a formula and then you see an AQ in parentheses, all right, you probably remember this. AQ means water. You have, in this case, sodium chloride and water, and the AQ tells me it's a homogeneous mixture. Checking out question 13, in which sample of matter can the proportion of its components be varied? If I can change up the amount of the components, I'm talking again about a mixture, and lo and behold, here it is, right? This is potassium bromide with the AQ in parentheses, and it's a mixture. For 14, according to kinetic molecular theory, the particles of an ideal gas have. Students get confused with this, and I totally understand. It's an interesting concept, but kinetic molecular theory is how we explain behaviors of gases. And we simplify this whole idea of how gases interact, and we call then the gas an ideal gas. No gas is totally ideal. Obviously, we have real gases. Okay, but ideal gases, we ignore things like the fact that they would have attraction between particles, the fact that the gas either atoms or molecules take up room in a container to begin with, things like that, that their motion, it doesn't have to be always at the same speed, and that it's, always straight line motion. Again, these are it's kind of a list of things that are followed with an ideal gas and then what real gas behavior is. So in this case, we're looking for one from the list of how an ideal gas behaves. Ideal gases, we say no attractive forces between them. That can't be our answer. But we do say for an ideal gas that their motion is random, constant, and in a straight line. And I believe this is going to be our answer. And for choice 3, a greater size than the distance between them, no. And collisions that increase the total energy of the gas, no. Energy stays constant. So the answer for question 14 is 2. For 15, a chemical reaction is most likely to occur when reactant particles collide with the proper orientation and the proper energy. Why do we say that? Because we want to be able to break the bonds, the attractions between the atoms. The proper orientation means that they're hitting at the proper angle. And if you don't have enough energy, they're just going to bounce off one another and not do a darn thing. So you got to break bonds in order to form bonds, and that's what we're talking about here. For question 16, we're at SDP again, right? Standard temperature and pressure. So all of these samples are exactly, again, at the same temp and pressure. Which sample contains the same number of molecules as 44 liters of NO2 at SDP? Liters is your unit for volume, all right? The same number of molecules, no matter what the gas is going to be at the same temperature, pressure, and volume. So literally all we're looking for here is choice 2. If it had said atoms, we'd have to be careful because then we'd have to look at the formulas for the gases. It didn't say that, it said molecules. So if it says molecules, you're at SDP, you're given volume, then just look for the matching equal volume. For 17, based on table I, which chemical changes exothermic? Exothermic is definitely a word that you need to know, right? When you have an exothermic reaction, energy is being released, so it's a product. The opposite is called endothermic. Let's check out reference table I, and then just play the matching game. I've already made note of the 4 equations here. And it's pretty easy to see that 3 of them have plus signs and only 1 has a negative sign. And that actually is your answer. The negative sign means that I have an exothermic reaction. And if you were asked to put this energy back into this reaction, you never use the negative sign. Instead, we would put the plus sign and the amount, in this case, the 84 kilojoules. The sign gives us direction. Now, the other thing with reference table I, just in case you forget, here at the bottom of the table, it tells you that the minus sign is for an exothermic reaction. You just have to go and check out the reference table. And remember, practice with the reference table. Don't just say, yeah, I got it. You have to go through everything, because if you don't, it's so easy to make a simple mistake on the test. So for 17, it was choice 3. Moving on to 18, which term identifies a factor that affects the rate of a chemical reaction? Right? So the rate is the change in something over time. All right, in this case, it would be probably the concentration of the substance. Decay mode, that has to do with nuclear reactions, not chemical. Same thing with isotopic abundance, and same thing with nuclear stability. Nuclear chemistry is a unit that you study that has everything to do with what's going on in the nucleus. When we're dealing with the rest of chemistry, at least with your course, we're dealing predominantly with those valence electrons and how the atoms are interacting with other atoms. For question 18, what's going to affect the chemical reaction rate? Surface area. Question 19, which phrase represents the net amount of energy released or absorbed during a chemical reaction? What we're looking at here is enthalpy. You should have seen this symbol delta H during the school year, and we're dealing with the stored energy of the different substances that make up a reaction. Stored energy is your potential energy. When we're looking at a reaction, it's the potential energy of the products minus the potential energy of the reactants, which is choice 4. For 20, a catalyst increases the rate of a chemical reaction by providing an alternative reaction pathway. That is, if we take a look at a potential energy diagram, remember there is the middle part of the graph that goes up, and then it either ends lower than where you started because energy is released, that was exothermic, or higher than where you started, which is endothermic, and energy was absorbed. But it's here that the catalyst affects the rate of reaction, and it somehow changes the reaction pathway, and it does it by lowering the activation energy, which is the energy to go from where you start to the toppest. That's not a word. The top of the graph. That is choice 2. Okay, for 21, systems in nature tend to undergo changes towards a fact jack, right? They want more stability, but more disorder. More stability means they want to be at a lower energy, so right away cross out 3 and 4, and more disorder, which is choice 2. We have 9 questions to go. Good for you if you've stuck with me this long. That's awesome. You're well on your way to get ready for this exam. And with that, let's look at 22. Atoms of which element bond with each other to form chains, rings, and networks? That is your special element known as carbon, and the study of carbon compounds known as organic chemistry. 23. A molecule of which group contains the OH functional group? Now, there is a reference table for this. Let's check it out. Here it is, reference table R. The OH group, I just go ahead and start from the top. It's here in the second row. It's for alcohols, if you didn't know that already. And how do I identify an alcohol? Well, on the molecule, you're going to see the OH. But in the name, you're going to see OL as the ending. With that information, when I come back to 23, my answer then has to be for the 1-propanol, or choice 4. In 24, which statement explains why butane and methylpropane are isomers of each other? Again, I'm dealing with a definition here, right? If they're isomers, what that means is they have the same number of the different elements. In this case, it's going to be C4H10 as the total number of carbons and hydrogens, but they're going to have different structures. So they have the same molecular formula, but different structures, and that means also they have different properties, although they didn't address that here. For 25, molecules of which 2 substances contain a multiple covalent bond? You should have learned that carbon bonds with itself fairly easily, and that's why there's so many organic molecules around. Single bonds, double bonds, and triple bonds. There is a reference table you can check out if you get confused, and let's go take a look. All right, here at reference table Q, I have my alkanes, my alkenes, and my alkynes. These are known as hydrocarbons. Why? Because they're only carbon and hydrogen atoms that are parts of these molecules. And you see 3 different endings, and the names have those same endings. And that corresponds to single, double bonds, or triple bonds. So if I'm looking for multiple bonds, I'm looking for enes and ynes. Just running through the choices, it can't be choice 1 because I have an ane. That's a single bond. It's going to be choice 2 because I have ene, double bond, and yne, triple bond. It can't be number 3 because, again, ane, single bond, same thing with 4, ene is a single bond. For 26, which term identifies a type of organic reaction? There is a basket of reactions that you need to know when it comes to the organic unit. They're on my review sheet. If you don't know them already, check it out. I'll put the link in the description. I still have that webpage up. I haven't done a lot to it in a long time, but the review sheets are still there. All right, so here we're identifying a type of organic reaction. Well, deposition, that's a phase change. A gas directly to a solid. It is substitution is my answer. Solidification, of course, that's, going from a liquid to a solid, and vaporization from a liquid to a gas. So the other three are phase changes, with substitution being our answer. For question 27, which statement identifies where oxidation and reduction occur in electrochemical cell? Well, there's a couple of things you need to know, and I'm sure your teacher went through this with you. Oxidation is the loss of electrons, reduction is the gain, right? Leo the lion goes grr is the way that typically we try to remember it. Loss of electrons, oxidation. Gain of electrons is reduction. Now, they're not going to occur both at the same electrode. Okay, so we can cross those out. The other thing to keep in mind, there's another saying, an ox and red cat. So oxidation takes place at the anode and reduction takes place at the cathode. So that's important here as well. And let's check out 3 and 4. Oxidation occurs at the anode, anox, and reduction occurs at the cathode, red cat. That is the answer here, choice 3. So those are labels. One of the things you got to remember with a lot of this, they're man-made labels. They came up with these words, and you have to know where they apply. This is a fact. And again, remember, part A here is all about those facts and those definitions. You want to try to get your 30 out of 30 points here. For 28, which type of reaction yields a salt and water? Salts and water are produced when you have acid-base neutralization, which is choice 3. See, for all these 4 choices, you need to know what they mean. Combustion, while it's not the answer here, is when I burn something in air. Fermentation, that's when I take sugars and oxygen and I make alcohols. Neutralization, acid and bases neutralize one another, and polymerization, another organic reaction where I take small molecules and I make long-chained molecules. All right, 29, in which process are heavy nuclei split into lighter? Okay, heavy nuclei into lighter. Well, we're talking nucleus. Single replacement and double replacement are chemical reactions. They're not going to be here. So we're either talking fission or fusion, and you don't want to get confused. It is going to be fission. Fission is your nuclear reactor reactions. This is something like taking uranium and breaking it apart. Fusion, just like the word kind of means coming together, that's light nuclei coming together and forming heavier nuclei. So your answer here is 1. Finally, we are up to the last question of part A. Question 30, which statement explains the large amount of heat produced during a fission reaction? Well, you probably know this. You knew this before you walked into the door of a chemistry class, and that is E is equal to mc squared. A little bit of mass is converted into a heck of a lot of energy, which is choice 4. I hope this is helping, that you're getting a lot out of this walkthrough of part A, and I hope you continue to review and study leading up to the test. Good luck with all of your exams and what you're doing. I will be putting out a walkthrough for B1, B2, and Part C's. That's the rest of the exam. Remember, you need 50 points just to pass the exam. You want to maximize your points here in Part A. Have a great day, and thanks for watching.